Hello everybody, we're getting ready to do 5.2 of SAT Math Level 1 lesson, and it's about more advanced algebraic kinds of methods. Email me here for materials. 5.2, more advanced algebraic methods. We got 38 points here for notes for your notebook. And then we have a 66-point skill sheet at the end of this lesson. Overview of this section extends some previously covered algebraic skills related to factors, equations, and more complicated algebraic expressions. Factoring by grouping, pairs of terms. Some polynomials of 4 terms can be factored by grouping appropriate pairs of terms together, and then factoring out a binomial that both pairs of the terms. This would be an example here of that. We can factor out an a minus 4 out of this expression here, and then an a minus 4 over here as well. And then we get this here by using the distributive property and also the factoring by grouping method here. And then here's another expression here, x plus 5 can be factored out. And you have x squared minus 9 comes down here, and then this can further be factored into. So zeros of a function, a zero of a function is any value of a variable that makes a function evaluate to 0. The zeros of a function correspond to the x graph of a function. So what are the zeros of the function of this thing here? Defining 0 as a function f, find the solutions of the equations when f of x equals 0. So to do that, we're going to first section off this. We're going to divide up this 4-termed polynomial. And then we find out here that we have a common factor here of 2x minus 5. And then we have x squared minus 4. As the other binomial factor, which can be factored further into this here. Setting each factor equals to 0, then our x's would equal negative 2, 2, and then 5 over 2, which would be here. So you got a curve that goes something like this. The zeros are there, and the zeros of the function f correspond to the x-intercepts of this graph in the xy plane. So function f is defined, this function here is defined by the equation where k is a non-zero constant there in the xy plane. The graph of f intersects the x-axis at 3 points, negative 2, 0, 3, half 0, and c 0. What is the value of k? So here's our possibilities here. Since the x-intercepts correspond to the factors of a polynomial function, x plus 2, 3x minus 2, and x minus c, if the factors of the function are multiplied out, then you would find the product of the constant terms in the 3 factors here. So 4c would equal 28, c would equal 7. Multiply the factors of f of x together. So here we have this here, the original statement there. So we stick 7 in for c, and then we multiply these out. We get this expression here. Since k is a coefficient of the x squared term, k would be negative 17. So the correct choice would have been 17 in that case. Remainders and factors of polynomials in this trinomial here. X minus 3 divides evenly into f of x, since we get this situation here where we factor this out. This factors out, we get x plus 2, a remainder of 0. So also, when we stick 3 into this function up here, this If f of x is divisible by 3, there is no remainder either. If a polynomial is divided by a binomial of the form x minus c, where c is a constant, then the function value f of c is equal to the remainder. If f of c equals 0, then there is a 0 remainder, so f of x is divisible by x minus c, or equivalently x minus c is a factor of f of x. This also means that the graph of y equals f of x intersects the x-axis at x equals c. So it just means using the zero factor theorem of multiplication. That's where your graph intersects the x-axis. This is what this means. So let's get an example here of that. If x plus 3 is a factor of this here, and p is greater than 0, what is the value of p? So x plus 3 equals x minus a negative 3 is a factor of the polynomial f of negative 3 equals 0. So f of negative 3, we plug that in up here, then we get this trinomial here. And then if we factor this out, we get these two binomials here. P equals 5 or p equals negative 2. Reject since p has got to be greater than 0, so the value p would be 5, would be one of the intersects here where this curve would intersect x-axis. Simplifying complex fractions. So to simplify complex fraction, multiply its numerator and denominator by the lowest common multiple of all its denominators. Simplify, for example, here with this, multiply the numerator and denominator by x squared. So we get x squared plus 2x out of that. And out of the bottom we have x squared minus 4 is what we get. Then we can do some factoring and then canceling out here. These cancel, I get x over x minus 2 from that. As an example of a complex fraction, when x to the negative 1 minus 1 is divided by x minus 1, the quotient will be, here's our choices here. So if we do this here, this is what we have here. And if we multiply both numerator and denominator by x, we get 1 minus x over this. And then these cancel out and get a negative 1 over x. So that would be an example here of making this thing solvable by multiplying bottom and top by x. Solving fractional equations. Solve an equation that contains algebraic fractions. Clear the equations of its fractions by multiplying each term of the equation by the lowest common multiple of all the denominators. To find the solution to this equation here, for example, multiply by 6x, the lowest common multiple of all the denominators. So we have this here. So here's our denominators here, 3, 3x, and 6x. We multiply through everything by 6x. Then we end up with this expression here, and then we just work through the algebra by distributing multiplication and combining like terms, and we divide through by 14. We get x equals a negative 3 over 2. In the equation, what is the value of n squared? So we're going to solve for n to find what n squared is. Eliminate fractional terms, multiplying by 12 for everything. So we multiply through here by 12 on everything here. These cancel out. Then you end up with this big long expression here. You multiply through, then combine like terms, and then you end up with this thing here. You solve for n equals -5, and then -5 squared would be 25. That was a lesson on fractions and stuff. If you need more PowerPoints rather than video, if you'd rather learn by video, which is slower, you can go at your pace. You go forwards and backwards, etc. You need worksheets, online tutoring. Email me here and I'll help you out. Thank you.